I'm now starting the recording. Welcome to this first ECSCI webinar of the 2026 series. So as most of you probably know, ECSCI is a cluster of European projects now that work on critical infrastructure protection and critical infrastructure resilience. This includes projects on cybersecurity and cyber resilience. I'm a member of two of these projects, Cyber Aid, Vigilance, and founding member of the cluster. I kindly ask people to mute. Thank you. We have launched in the cluster, we have different activities of practitioners' interest, but also of academic interest. Since we have several new members in 2026 in the cluster, we have launched a series of webinars giving old projects, but also new ones, the opportunity to present themselves, to present their results or their ambitions to the ECSCI community. The first webinar is today. Three presenting projects are ResilMesh, Sonic, Miranda. We have already scheduled the second webinar in 2 months from now, September 21st. And the projects there will be Vigilance, CyberNemo, ECHO, and Cyber Aid. The third webinar will be some day in October, where we will circulate a DDoL. We have already subscribed interest from different projects, confirm interest. So we are going to confirm with them a date, and this will communicate it to you in advance of the second webinar. Just to say that as part of our activities in the ECSCI cluster, and together with some of the people that contribute to today's webinar, like Brian, we have just produced an open access publication. This is from the previous, if I'm allowed to use this word, generation of ECSCI projects. The book is open access, so you can access it completely free, and will be launched within July 2026. So it's really a topical book, and with recent articles. We will plan to do another book for them with contributions from the new projects, but this will come later in 2027. But if you have an interest, we are happy to know that you would like to contribute to this upcoming, to actually the fourth open access book. So today's webinar, 3 presentations, ResilMesh, Sonic, Miranda, 3 excellent speakers, Brian, Kitty, Matteo. I don't want to say anything more. I would like to give the floor to Brian Lead, our first speaker. Brian, please take the time to introduce yourself, introduce your project, and give your talk about ResilMesh. Just as a housekeeping rule, please, we can take 1 or 2 questions at the end of the presentation for Brian, or and then some more questions at the end of the webinar, or you can type your questions in the chat. Brian, the floor is yours.
Can you hear me?
Yes, we cannot see your slides yet, but we can hear you loud and clear.
And the slide set, can you see that?
No.
Not yet.
Okay. I think, John, you may have taken over the presenter role there. Maybe I should try to share my screen again. Let's try this again.
You need to start again. Yes, correct.
Does that work now?
Now we can see your slides, so you can start.
Okay, very good. Very good. Okay, John, thank you. Well, good afternoon, everyone. My name is Brian Lee. I'm the coordinator of the ResilMesh project. ResilMesh has been running for almost 3 years now. We'll finish in November. I'm from the Technological University of the Shannon in Athlone in the middle of Ireland. Shannon is the biggest river in the country, and the different campuses of the university are different locations along the river, hence the name. So let me say a little bit about ResilMesh. First, I'll talk a little bit about the project structure. Then I'll talk a little bit about the objectives, technical approach, and then I want to focus on maybe 2 or 3 contributions, which are ResilMesh has a lot of functionality. Some of it overlaps with other projects. I'm going to try and present that which is somewhat different or focused than other projects, which maybe differentiate ResilMesh a little. Okay, situation-aware enabled cyber resilience for dispersed heterogeneous cyber systems. That's quite a mouthful. I think all the projects in this call were really addressing dispersed, what I'm calling cyber systems, but probably better is critical infrastructure. So we looked at how we could frame it around cyber situational awareness and how that could help both security and resilience. Because again, resilience was called for in the call. So it's not specifically focused at the whole resilience model, but at some parts of resilience. So it's a mix of, it's a security system or SOC-based system addressing both cybersecurity, but also with certain parts focused towards resilience or helping operators improve resilience. Essentially, as we said, it's a cyber situational awareness-based security operations toolkit to help improve digital infrastructure cyber resilience. So initially, the project should have ended at the September, but we've extended it by 2 months for reasons outside our control. One of our open calls got delayed, and we needed to extend a little bit in order to complete that. So we have 14 partners from across, but spread across Europe. 4 in Spain, 3 in Ireland, and then 1 in many other countries. So basically, we said, what are the issues with modern digital infrastructures? And I use the term digital infrastructures, critical infrastructures, cyber systems interchangeably here. We're not thinking just about critical infrastructures, but also the infrastructures associated with, say, big enterprises as well. Because as we all know, multi-cloud is a solution for many people these days. Many non-critical infrastructures are deploying some form of edge AI here and there. So basically, overall, we have this characterized by what I'm calling digital infrastructures, are characterized by this high degree of distribution, or dispersal is the word I use sometimes. They're heterogeneous, very complex. And that brings many challenges in terms of essentially the attack surface and the attack surface management. Attack persistent threats. At the time we wrote this, I mean, we said they're complex, they're sophisticated, they're getting more sophisticated all the time. At that point in time, LLM-based attacks hadn't appeared on the surface. So certainly the attack situation is becoming even more serious and more critical than we had anticipated and discussed 3 years ago. And finally, there's a slow adaptation of best practices. Zero trust is becoming more common. I mean, zero trust is in the IT space initially, developed for IT systems, and we see Secure Systems Edge taking that out to the edge. But I guess the principles of zero trust, or some of the mechanisms underlying zero trust, such as isolation and zoning, have been common in critical infrastructures through the 64333 for quite a long time. So anyway, all of these things are contributing to issues and problems as we saw it back then in terms of digital infrastructures. So we tried to look upon the following approaches to deal with that. In the first place, we wanted to develop a resilient aggregation plane. So basically what we're saying is, as you move functionality to the edge in terms of edge AI, your security controls follow that. Also, your the types of clients we're dealing with, our operators have very diverse infrastructures. So if we look also at this issue of hybrid threats and the issues that are arising, particularly for characterized most frequent, I suppose, with smart grid operators and distributed energy resources, but also, applies also for railways and lots of other infrastructures. As we see these hybrid threats arising, we foresee the need at some point in time to have the infrastructure, the security controls infrastructure itself resilient, and to be able to withstand attack. So that's where we're going in the first place, to be able to deal with the deployment of security controls to the edge, to allow operators to structure those in whatever way they want. And then we want to put in resilience in there in terms of the collection of that data. So if some part of the network goes down, the data can be routed otherwise. We also want to give, if the system breaks down, that the events are not lost. That's the first type of reliability we're trying to build in. And then on top of that, we wanted to look at resilience issues around dynamic positioning and redundancy. So we looked at some form of, being able to deploy honeypots and other moving target defense, tokens around as well. The second part then was to look in terms, because we've talked about distributed networks stacked with dependencies between them. So in order to manage the attack surface management, we need better awareness of the services and assets and the dependencies on those. And I'll speak to this a little bit later. The third thing we looked at was helping CSIRTs to build organizational operation resilience. This we did through a series of exercises on a cyber range, one of our partners based in Finland. The fourth thing we wanted to look at then was trying to improve the types of algorithms and tools using AI. We looked at distributed anomaly detection on the edge, as well as AI-based correlation and some other tools. And I'll speak to some of those later as well. And then the final thing we wanted to look at was developing a situation assessment system for risk comprehension. So what do we mean? We mean taking the information from the asset management and the dependencies, and then being able to use that to calculate risk across the network and aggregate that up from the network. Okay, the technical concept. If you look on the bottom left here, we have the well-known cyber situational awareness framework, where we have perception, comprehension, projection. That's extended here for the OODA loop, where we have decision and action. So taking this concept, we sort of turned it on its head and said, okay, what does it look like if we want to take the data and move it up the way? So we have collection of data, aggregation data. We have the threat awareness that gives us the perception. We have the situation assessment, which gives us the comprehension and projection. And not shown here, we have on top a security operations plane, which gives us the action. So comprehension and projection in this layer, and then decision and action on our top layer. And so we structured the system accordingly. So what does that look like in terms of our architecture? Basically, we have something called ResilMesh Core, which is basically the aggregation functionality, asset management, and SIEM. That gives you very, very basic capability for security operation system. Bare core, but what's needed. We have this concept of a collaboration mesh, which speaks to the interoperability. And I'll come to that later. I don't want to say too much about it now. The threat awareness suite of functions, some of which I've mentioned, and then situation assessment and security operations. So our ResilMesh core sits on a collaboration mesh, the infrastructure plane where we collect the data, and then we have these three extension modules, I would call them, which give you the perception, comprehension, and mitigation. Okay, that sort of in a nutshell is a high-level view of the motivation, the way we approached it, how we structured our objectives, and how we structured our technical components to meet that. So where is it a little bit different? I'm going to talk about the collaboration mesh, a little bit about the security assessment. Under the threat awareness, I'll say a little bit about threat hunting. I won't get into indicators of behavior, other than maybe explain what they are. So let's look at what we call the collaboration mesh. Part of that I described already, which is related to our objective one. We wanted to build resilience into the collection layer. And this we call the connectivity mesh. So we looked at using a service mesh to do this, okay? But we stood back from the main cloud native Istio Linkerd once we discovered that NATS, which is a broker, message broker like Kafka, has a built-in capability to do service mesh. So we immediately focused on that. And basically what it does is, NATS is very lightweight, very powerful. You can distribute, because it's a pub sub message broker, you can distribute your controls, onto very resource constrained devices. So it's very lightweight, but it also deals with very, very large volumes. And on top of its basic message sending capability, it offers assured connectivity as well through something called jet streams, which I'll refer to in a few moments. So what this means then is that in your infrastructure, your collection infrastructure, you can deploy what you want, where you want, and you can set it up so that you're assured that delivery will get through if some parts of the network go down. You have that resilience connectivity, which I won't say essentially comes for free in NATS because the capability is there. You just have to configure and set it up to use it. On top of that, the second type of mesh we wanted to talk about was what we call it interoperability mesh. This is in some sense well known. We want to standardize protocols. We want to get devices talking to each other. Gartner formalized it a couple of years ago in terms of what they call the cybersecurity mesh architecture, which we saw as a trend at that time, and decided to use that idea, but also to look at what was happening in the Open Cybersecurity Alliance, which is a sub-organization of the OMG of OASIS. So there's a lot of good stuff going on there. And we wanted to utilize that and sort of take the principles from the CSMA. So I'll say a little bit about that. And the idea there is really founded on connectivity through REST best practices and standardized protocols. Okay, so let's talk a little bit about the connectivity mesh a little bit more. I've alluded to this already, that NATS has this idea of a service mesh built in. And here you can see, for example, that with NATS at the core, you connect your different services and deploy them wherever you want. The standard capabilities that you get from a service mesh, such as Istio, are all given for free in a sense via NATS. I've included a link here which people could take to see for themselves if they want to examine a little bit more about NATS and what it does. So that was our basic capability. Now, we ran a number of open call projects. One of those was called Chameleon. So what Chameleon did, I should say that when we built this up first, we used Docker, but in our own work, we used Docker Compose because we had a limited set of functions that we tested in the scope of the project. But part of what we wanted to do was to see how this would work with Kubernetes. So what Chameleon did is it built a Kubernetes-based service mesh on top of NATS. And it included this JetStreams streaming facility, which gives assured connectivity. It persists data. It ensures that no messages are lost. As well as that, they included moving target defense. So the two main features around this, one was, which we wanted from the beginning, and then this idea of the moving target defense was an innovation they brought in themselves. So what it means is that your pods can be connected and disconnected and moved around at will. So your attack surface within your layer is all the time moving, and your attack surface as such then becomes impossible for an attacker, even if they get in somewhere. After a short period of time, the whole thing remaps itself, and so they're lost, as it were. So that was from our partner project Chameleon. So talking about the interoperability mesh, in high-level terms, it's creating a collaborative system to secure complex and distributed infrastructures, composable, interoperable security control through a mix of open standards, proprietary APIs, and point integrations. And that's a key thing there, because the normal thing when we talk about interoperability, it's all about standards. But as we know, there are standards and there are standards, and there are many standards that don't work, or we could standardize the standards again if we did in many cases. So sometimes you have to reach for practical solutions by having, you know, a well-established, well-defined REST interface. And so that's what we're trying to do here, is it's take what the standards that are there and use them, but also make available our functionality through well-defined interfaces. The other thing was consolidated dashboards, because the CSMA addresses more than just analytics. It also addresses things around policy, which we don't get into here. But the idea of having a dashboard that takes data from a number of different back-end tools, or back-end controls, and excuse me, blends that data to do joint analytics is also something we looked at. So as I said, we took sort of inspiration from both the Gartner cybersecurity mesh and also from the Open Cybersecurity Alliance, particularly the Open XDR. So just to address the idea of composability, I said before in the beginning here when I showed this picture, we had this ResilMesh core, and we have defined a number of sort of well-defined integration points, and one of which hinges off Wazoo, which is the seam we use. That's an example of a well-defined REST interface that can be used, and it provides hooks for you know, some of these things as well. Sorry, was that a question? Or? Okay, and then these ones here are built in a hierarchical fashion. So the threat analytics feeds the situation assessment, feeds the security operations, and that goes back to our CSA stack we showed at the beginning. Okay, OpenXDR is from the Open Cybersecurity Alliance. It's a means to, or an effort to define a common set of standards and interfaces and libraries. They look at threat intelligence, they look at ingestion, automation, orchestration. So we have things like STIX, which we all know and love. We have OCS, we have OpenC2, we have Cacao. So in this area, we use OpenC2 within the project. Again, one of their partner projects from Scientific in University of Oslo is building an extension using Cacao. Those guys are involved. Vasilis Mavridas very much involved with the Cacao standardization. And also we worked with a small group from within the OCA. They had a working group called Indicators of Behavior, which was led by Johns Hopkins. And that's been running for a few years. And basically what their definition of indicators of behaviors are, the basic idea that indicators of compromise aren't, you know, they're not timely and they're not much used by themselves. And besides which, a manifestation of a behavior can take many different forms. So what these guys wanted to do effectively was to create a STIX objects that would allow you to capture all the steps in an attack, a multi-step attack in effect. So they created a new behavior object, and then the sequence of those behavior objects defines the multi-step attack. And associated with that object, they have defined detection objects and playbooks. So it's a very comprehensive set of, and the idea, of course, was to raise the cyber threat intelligence to a somewhat higher level. We took some of their ideas and we built a sort of a simplified version of that so we could represent some attacks and detectors. And then we shared that between two of the partners within the pilot, and then that worked out quite well. But it was a simplified version. You know, you're constrained by time as well as everything else, but it proved the concept, so to speak. So that's the idea then around our collaboration mesh. How do we improve connectivity? Sorry, how do we improve interoperability and collaboration, both at a connectivity layer, but also at a am I doing here time-wise? But also at the interoperability layer where the controls live. Finally, situation assessment. Okay, I'll skip this up a little bit because I can see I've got about 5 minutes left here. So we use a graph-based data model called ISM, and that allows us to capture, well, just about anything really. Here you can see hosts, services, networks, user, data vulnerabilities, and also the relationships between them, the vulnerabilities found on the host connected to the network, and so on and so forth. That's based on open source. Well, this is all is open source, but it's based on a model or some work from the University of Masaryk in Czech. It's called Cruzo. Some of you may have come across it before. So using that, and then we customize that to different applications and different use cases, or extended it, I should say. But basically, then it allowed us to capture it allows us to model the assets, the services, and the missions. So we were able to model all the different criteria and entities within the network. That was partly extended as well because with another tool, which is built on ISM, is to look at how does the network or the assets in the network support different services, which in turn support different missions. Now, a service at this thing could be a level service. It could be like a VPN, for example, or it could be some kind of video streaming service or something at that level. How are they combined to support different missions? And this tool allows people to model that and see, which are the more critical assets that they have, and then that criticality can then be reflected back into these assets here, so we know which are the most important assets. That allows us then to model hierarchical risk within the system. So we can model the risk of each asset, each node in the system, and that's combined on calculated from, we use the CVSS4 approach, but we don't use the CVSS4 actual, it's not a CVSS4 implementation, just kind of using the basic ideas there. So we have a base metric, a threat metric, and environmental metrics, and any other metrics one wants to add in. So we adapted that to say that the risk is built up from a number of risk factors, and those can be weighted. Some of the factors that you can consider in getting the risk for a node, vulnerabilities, attack exposure, the attack surface exposure to maybe hidden infrastructure or shadow infrastructure, asset criticality, which I've shown from the previous page how we get, and threat intelligence. Now, threat intelligence here is shown, but I guess also the threat situation, which you can read from your scene. So the way we've designed this, it's quite simple, really. You define the risk as a combination of factors, and you define software interface that the factors can provide their information by. But the factors themselves, or the code that implements them, can be anything from a 2-line Python implementation to a 5,000-line very comprehensive deep learning model. It's framework agnostic here when calculating the risk. And basically then what we can do is we can aggregate those up. We can use the ISM to define sets of objects that might be related to a mission, or might be related to a particular location. And from that, then we can see what the criticality of any particular entity is. This is a screenshot of the tool we built, which is very much focused on networks, but also can be used to look at, as I said, sets of objects that are business related. Finally, then, to talk about threat hunting. Threat hunting, as you probably all know, is a proactive approach that you take. You're assuming that there has been a breach, and you're then looking for threats and adversarial behaviors. We looked at using, there are quite a few existing threat hunting processes out there. Very well-known one called Peak, which is used for Splunk. And there are quite a few around from the early days, and they all basically follow the same structure. We looked at that, and we looked at the existing ones, and we looked quite a lot at work that was being done in MITRE around using TTPs for threat hunting. And then we devised a threat hunting methodology for Wazoo, which, as I said, is quite like the others in many ways, but it also has very Wazoo-specific issues in its implementation. We integrated that with Wazoo and OpenSearch, and then in a later stage, we developed LLM tools to follow on with that. So some ideas based on OpenSearch has the idea of notebooks, which are a bit like Jupyter notebooks, except you can't really develop in them, but they have the same concept. So in there, we mapped this thing in as a document into that, and we implemented various parts of these steps using the tools. Finally, then we built a multi-agent system to be able to act as a front end or query, which would, because with all of these things, you have to build these very sophisticated queries. But we tried to make that easy for the end user by building this multi-agent system. So very simple here, you can ask a question like, show me the distribution of security events for the last 10 hours, for example. You get back an answer, something like this, that shows you where those events have been distributed. It can do much more than that. And like every tool, it has lots of good things, and it has limitations, I think, any LLM-based tool, because queries can be very sophisticated and they can be scaled quite large. These tools can deal with that quite often. But if you've tried using Google Scholar Labs, you'll see you hit the limits on that as well if you ask something too complicated. So that's it in a nutshell. And I think that should be more or less 25 minutes. Any questions?
Thank you very much, Brian, for the presentation. Shall I ask, may I ask if there are any questions for Brian? Let me also check the chat. A lot of interesting stuff, because you know the project has been running for quite some time. You know, I have actually, Brian, two questions, right? Since I don't see anyone else asking. One question is in the threat hunting. Did I get right that you use an AI LLM agent?
Yes.
And in this case, this taxonomy you have developed, right? I guess to give context to the agent. Does this relate to MITRE, you know, to some standard knowledge bases like CV or MITRE? Is an overlay on top of them, or is something that you have entire developed from scratch? Because for me, this intent thing, right, the delivery of intents is really very interesting. But do you do this from scratch? Is something that ResilMesh defined, or is starting from existing knowledge bases? That's my question.
Well, what we did, John, was we built the process first, right? Then we decomposed the process into intents, high-level intents. Once we had that done, we then went and looked. We compared quite closely. We developed our own set of intents, right? Mm-hmm. And then we looked. We spent a lot of time looking at the MITRE document, TTP-based threat hunting. Okay, so we compared against that, and from that, then we finalized a set of intents. So I would say, in the first place, we built our own intents, and then we refined it against the MITRE one. And then we decomposed each intent. Again, you know, if you look at the threat hunting there, in many cases, the search tools they use, they break down to, you can, for example, calculate Z scores. A number of them use isolation forests or random cut forests for anomaly detection. So you see that there are some things across a number of them. If you go back to look at something called Tahiti, which is one of the original threat hunting approaches defined by, I think it was some finance guys in Holland, they laid out a sort of a set of ideas that have been duplicated in many cases. So collecting all that kind of thing and reading some academic literature as well, and understanding what TTPs, we defined the process and then defined the set of intents. Thereafter, we broke each intent down to a set of sub-actions. And they were, you know, there could be 5 or 6 sub-actions for each intent. At that stage, then we had a generic taxonomy. Okay. And so what we did then was we mapped each of those into queries based on Wazoo. So we had a query layer underneath. Now we could just as easily implement that for Splunk or anything else, because the queries are specific to the particular SIEM. And the part we implemented, we built it around Wazoo. So it's all SIEM based. But some of our intents, for example, have to do with threat sharing. So, you know, looking again at the industry standards and approaches, we differentiated between strategic threat intelligence and operational threat intelligence, which again is a breakdown originally comes from the UK and CSC. Strategic is more, you know, what attackers might do and where they're going, whereas operational is kind of more focused at a TTP level. So those we didn't implement, but we would take that in the kind of same way and kind of break it down further. So we had a taxonomy of functionality, which is represented by the intents, basically.
Okay.
And maybe it's developed by partly ourselves and partly best practices from other parts.
Yeah, it's a combination. Yeah, maybe I will try to read more in your chapter. I don't know if it's in there or
Yeah,
find about the project. Thank you, Brian.
we're publishing a
thanks a
paper on
lot.
it now in the next few months. Okay, great, John. Thank you.
Excellent. Now we move to our second speaker, Kitty. Actually, I think Kitty, you represent Sonic is one of the new projects, right? A newly started project, right? Unless I'm.
Yeah, that is correct.
So the floor is yours. Please introduce yourself, Trastilio, and of course Sonic, your project. The floor is yours, Kitty.
Will do. Give me a second to share.
We can see the slides. Yes.
My full screen, right?
Yes. Excellent.
Okay.
Thank you.
That's great. Thank you. Okay, great. Thank you very much. I'm Dr. Kitty Kioskli. I am the CEO and co-founder of an SME based in the Netherlands called Trastilio. And I'm here today to present a very new, as John kindly mentioned, project which started a couple of months ago. The project is called Sonic. So it's a security-oriented nexus for intelligent commodity solutions marketplace. And Trastilio is the dissemination and communication leader of the project. So, as I said, I'm from Trastilio. This is a consultancy working around cybersecurity trainings, AI trustworthiness, risk assessment and management, and behavior change and cyber psychology. So we are also certified with ISO 27001. And the project that I'm going to briefly present today started just in January, and it will last for 36 months, 3 years. It's under the Cyber 07 Key Tech topic, and our consortium is quite broad and interesting, I could say, as we have 7 SMEs. We have 1 SOC provider, Adacom, 3 academic institutions, and we are spread in 7 EU countries. So our coordinator is Athena ISI with Professor Sotiri Ioannidis, and our technical manager is the University of Cyprus with Professor Ilias Athanasopoulos. As I said, Trastilio is the dissemination and communication leader. So this proposal was written while identifying some motivations around the needs in the landscape. For starters, we saw the rapid growth, of course, in AI-driven cloud edge and HPC architecture, which challenges the traditional security tools. Also, there were some very obvious visibility gaps, and we had this very complex deployment systems with which lead to high false positives and missed threats. And then we saw the operational burdens from SOC. So there were fragmented tools requiring manual processing by high-skilled professionals and increased response and costs. Also, there is a very obvious lack of standardized processes in order to identify some unsafe tool behaviors. And lastly, the last motivation that was identified when writing this proposal was that there were many current tools requiring data decryption for analysis, which created a very big security risk for sensitive data. And also, organizations do tend to struggle to balance the need for deep security insights with very strict GDPR and NIS2 privacy mandates. So mapping the motivations alongside with the challenges were the primary steps for this project. So the challenges were threefold. First of all, the limited operational impact of CTI, so cyber threat intelligence. So existing solutions related to CTI did lack very much the contextual awareness and automation, which led to reducing the effectiveness in supporting accurate security decisions. Also, the second very big challenge was the evolving threats and advanced attack techniques. So modern cyber threats do demand a scalable detection and response mechanisms that will be able to combine the behavior analysis, the advanced vulnerability, malware analysis with AI. And thirdly, the fragmented and evolving EU cybersecurity policy landscape. And this is a challenge for everyone working in the field. So to be able to ensure the compliance and the alignment with all the EU frameworks which are available and necessary, like the EU Cybersecurity Act, the Cyber Resilience Act, NIS2, remain very challenging. And we have also the national implementations, the evolving obligations, policy-aware security solutions all across the member states. So taking all this into account, if there is a problem, please mute your microphones if that's available to you. So taking all this into account, we did create Sonic, and Sonic aims to deliver innovative and deployable cybersecurity technologies in order to advance CTI, cyber threat intelligence, and operational resilience across infrastructures which would be modern and heterogeneous. So our main aims are two. First, to leverage advances in AI, LLMs, parallel processing and cryptography, and secondly, to provide scalable, automated, and accurate threat detection, analysis, and response. The objectives of this project are we have 7 main objectives which we are following thoroughly. And as I said, we are quite early in the project, so that's why I'm building more on the landscape rather than tangible results. So we just started. So our objectives are to develop and deliver a sophisticated CTI solution, which would integrate tools which will be provided by our consortium for several purposes, such as accurate infrastructure bookkeeping, interoperable integration, and automation capabilities with CM and SOAR platforms in order to promptly be able to detect and also to mitigate incidents through security policy-driven response capabilities. Also, we want to develop and deliver an advanced monitoring and response solution that leverages AI for behavioral analysis, accurate affected component identification, anomaly detection, and also neutralization of using cyber attacks. A third objective of our project will be to develop and also deliver a modular malware analysis environment that will leverage ML, machine learning, in order to identify any malicious behavior via code analysis and also system interaction. Also, we will develop and deliver a very interesting vulnerability management toolkit that incorporates fuzzing, penetration testing, and AI for enhanced coverage and efficiency. Further to that, we will develop and deliver a sonic forensic visualization toolkit for more effective incident investigation. Also, because we're very ambitious, we will also design and develop and also deliver a suite of algorithms for privacy-preserving data harnessing. Lastly, we aim to implement all the above aims and objectives into a sonic marketplace, and this will be our final outcome as a project. Which will be designed to the needs of various cybersecurity actors, actually, and will host the complete set of the sonic technologies provided by the partners and developed further as a result to the work that we are all doing, and interfacing them in the form of Dockerized network applications with openness to integrate additional cybersecurity solutions set by end users. So the marketplace will also have the capacity to articulate and adapt additional solutions in the form of network applications, yes, as I mentioned before. So the marketplace will offer via a smart marketplace to empower European SOCs and cybersecurity actors, and will strengthen cyber resilience, and it will be a coordinated European cybersecurity ecosystem. So in this slide, we can see the reference tools which will feed the marketplace, and it will be easy to deploy. It will be easy to be combined, and all these will be fed by our partners. We have 4 main categories of the tools. We have the monitoring and cyber threat intelligence, where we have tools like IDS and Interly Cloak. We have the vulnerability management for tools, including some fuzzing and mutation prioritization, etc. We also will have malware analysis and orchestration. So all these tools will come together to build the marketplace, which will be agile and adaptable to feed into more tools if needed. So our methodology is a 4-step methodology, easy to implement. So we have the requirement definition, which we are doing right now. Is the work we are doing at the moment. Then we will proceed to the design and specification, then to the implementation, and of course into the validation and final delivery. Our work plan is straightforward. It includes 6 very concise and clear work packages, which is a very common formula in EU projects. So we are starting with our project management website work package. We have our the requirements, as I mentioned before, which will be our whole work package too, which is progressing on right now. Then we will do the development of adaptive security intelligence modules. When this is finished, we will move into the Sonic marketplace, which is the most important part of the project, architecture, design, and integration. We will then validate, and meanwhile, throughout the whole project, we will disseminate the results, and at the end, we will do some exploitation. So regarding the evaluation and validation, this is a 3-step process that we are following. So we are starting with the real world operational trials, which will include the sector-specific validation and the analyst-centric optimization. When this is concluded, we will proceed with performance and interoperability benchmarking, which will include efficiency metrics and ecosystem integration. And lastly, we will have advanced AI training and data contribution, which will include the privacy preserving intelligence and also quantifiable results. So we want to deploy state-of-the-art technologies in the area of cybersecurity, and that's the main expected outcome of Sonic project. We also aim to have as outcomes the identification of critical gaps, utilization of advanced technologies, malware and vulnerability management, deployment of core security solutions. We want to also make sure that there will be EU technological independence, and also to finally be able to deliver the Sonic marketplace. So as future directions, we are ambitious to work through scalability and expansion and international collaboration, while also working on continuous innovation and sustainability. And this will include also collaborations like with ECSCI cluster with other EU projects, and we have also created a newly founded cluster now called CRSN, which includes all the projects which were funded are under this topic that Sonic project is funded as well, and we are hoping to also come together with ECSCI and do some very and our long-term vision is to have a solid sustainability plan, which will be fed by the community-driven growth and integration with the EU and global cybersecurity trends. So I invite you to scan this QR code if that's available to you, and follow us, engage with us. We are running many events which are very interesting, and I would like to thank you for your time and attention, and John for making this extraordinary effort to organize all this. And I do remain at your disposal for any questions which I'm happy to answer. Thank you.
Very much, Kitty. Are there any questions to Kitty to this very interesting presentation, or anything on the chat? Don't be shy. Feel free to ask questions. In this community, we ask questions. I don't know if anyone wants to ask something, but I would like. I understand that the project is quite new, but I would like to understand 2 points that have attracted my attention. So the first one is in the marketplace, right? So if you have like a system on chip system, and this comprises different components, do you orchestrate the security or the safety function from the different providers so that I can deploy safe the bigger system? So this is my first question. And my second question, you didn't talk too much about this, but I saw a thing which is XAI library, right? Explainable AI library. So what does this give me? It gives me configurations, priorities for vulnerabilities, and how do you really plan to evaluate that this is useful for a security analyst? Those 2 points. I don't know if there are any other questions, and I understand that these things may not be implemented yet, but I would like to hear more about those two points. One on if I can orchestrate different security safety functions. Second one is whether this ECSCI library explains what configuration, priorities, and how do you validate it is really useful.
Okay, thank you very much for your questions. Yes, it is very early on, so I will, regarding your second question, it's still, we don't know yet, it's still under discussion. So we are just starting, we are at the requirement phase. And regarding the security functions for the tools, the same applies. We will have to create some guidelines and create all the different, security requirements from the tools in order to make sure we have probably manual and delivery to the end users. We are very early on, but I'll keep these two questions and pass them to the consortium as well because they're very interesting.
Yes, keep them as feedback, right? Especially, because everybody's talking about XAI and explainability in these in such use cases. How do you really measure, right, that is useful for the analyst in the end?
Yeah,
okay, thank you very much, Kitty. I don't see
you.
any other questions, right? Don't be shy, right? Or even type your questions in the chat. But since there are no more questions, let's move to the Miranda, to the third talk for today. Matteo, are you with us?
Yes.
Take the floor.
Yes.
Take the floor and introduce yourself, introduce CNR, introduce Miranda. Take your time. Thank you very much for being with us today.
You're welcome. So, good afternoon to everyone. Let me try to share my screen. Okay. Can you see my presentation full screen?
And see the screen, not yet the presentation. Maybe.
Okay, let me try again. Can you see now?
Yes, now you can. We can see your slides, Matteo. So please.
Okay, perfect. So my name is Matteo Repetto from CNR, which is the largest research institute in Italy. We are around 7,000 researchers here, and I am the coordinator of the Miranda project, and I'm a research scientist at CNR working in cybersecurity issues, especially for what concerns visibility orchestration aspects. So Miranda started almost 2 years ago in September 2024 for a duration of 3 years, like many other projects, with a total budget of around 7 million euros, 14 partners and 3 use cases. So we are a well-balanced mix of both industries, SMEs, and also some universities and research centers to bring the necessary long-term perspective to this innovation action. We cover several countries in Europe, as you can see here. So, what is the main concept for Miranda? Miranda builds on the concept of digital services and most of all of their interconnections. So we have a lot of services deployed around us, cloud services, IoT devices, network infrastructures, cloud services, data sets, and these are incrementally connected by different kinds of relationships like APIs or even other kind of manual relationships, let's say. So this creates a lot of dependencies and what is called, the supply chain. So the basic understanding is that there are a lot of threats coming from the supply chains, and also there are surveys out there that estimates how much organizations have already been affected by threats in the supply chain and also will be affected in the next year. Probably the most known aspects about the supply chain is the security of the software supply chain, but we moved the scope in a different direction. So we broadened the scope to the service supply chain, which is a bit different from the software supply chain because we move the scope from the development perspective to the operation perspective. So we are interested in the threats and attacks that can come at runtime, not only in the development of the software, but also in its operation. And also the scope goes beyond the plain software because we also look at running services like infrastructures, cloud infrastructures, telecom infrastructures, and things like that. So the purpose is to improve the current practice here in Europe, where we have currently the NIS2 directive, and we found that this directive has some limitations, probably derived from the current lack of collaborative cybersecurity operations. So basically, if you look at how this directive is implemented in the member states, we found that usually it is limited to the identification of the suppliers in your supply chain, and this is something that it's not done automatically, but you must register manually your suppliers and update every year this list. Also, the scope is quite narrow so far because it only addresses the operators of critical and essential services. Okay, we all agree that these are the most critical entities in Europe, but often threats also affect other kinds of entities and organizations. So it is important that the framework is more scalable and more easy to be used by everyone. And finally, we noted the prevalent reactive, static, and fragmented approach, where each provider is expected to report cyber incidents, to perform some kinds of cybersecurity obligations, and also to implement risk management. But these often are operations carried out by each provider independently, standalone, without a lot of collaboration with the others. And also the only kind of collaboration expected so far is in a hub and spoke manner. So everyone is expected to report. Everyone is expected to report to the national authority, but there is no direct interaction between providers. So what is the concept of Miranda? We start from the consideration that, okay, it may be quite simple to create an overview to discover interconnected services to my application, to my system, to my framework, but often we cannot know what is behind. So every service typically relies on other services to be implemented of different kinds, different infrastructures, different data sets, and things like that. And it is very difficult to know this information because it is only known to the specific providers that implement the different solutions. So for instance, in this picture, you see a lot of services highlighted and interconnected between them. But each of these services could have implemented on top of additional services. And and it is difficult to discover in a systematic way all these relationships for a lot of privacy and confidentiality concerning issues. Also, these kind of services have already in place their cybersecurity measures to protect them against attackers, but this is usually done in a fragmented way. Each provider independently managed its own security services without collaboration with the other. And the problem, and despite the fact that we have today a lot of interfaces for consuming, combining, and self-provisioning digital services, we don't have, or at least we have a very limited interfaces for also self-managing security. So the main purpose for Miranda is to overcome this limitation by providing the concept of cybersecurity digital twin. What is a cybersecurity digital twin? It is the extension of a well-known concept of digital twin applied mostly for physical systems to digital system. So here, since a digital system is already a kind of, it's not typically a physical system, it includes a lot of assets which are virtual or software-based, so it's not a physical system. The idea for a cyber security digital twin is something that is able to understand, follow and anticipate cyber threats on underlying digital systems. So basically, there are already applications of cybersecurity digital twins in the literature, but in many cases they are plain digital twins of a physical system, also including digital assets that are used to exercise specific cyber threats or cyber attacks. In our case, we want something different. So the main purpose here is to build a sort of models of the attacks strictly connected to the underlying digital systems. So the idea is a digital twin. So we want to have bidirectional flows of information, both for collecting and monitoring data and also to apply security controls on the system. And the real challenge here is the scope, because we are targeting digital service chains. So we are targeting to collect data and to apply controls in a multi-ownership environment, which is very challenging because of the different trust relationships between providers. On top of the cybersecurity digital twins, based on the advanced features it tells us, we want to improve also collaborative cybersecurity operations. So we want to revise typical detection, monitoring, response processes in order to build on the knowledge, on the specific capabilities of this digital twin. So what is the basic approach for building this concept? The idea is that each provider builds its own twins of its infrastructure, its digital assets, in terms of resources, relationships, dependencies, vulnerabilities, and so on. And then these different models are combined together to create a large digital twin over the whole computing continuum. We think that each provider has different trust requirements with the other and trust relationships with the other providers. So the idea is that this digital twin is not something that could be shared entirely. There will be some kind of opacity on the information exchanged between the providers. So providers that I trust, I can give him full visibility over my infrastructure. Provider that I don't trust, I will not give them any visibility over the underlying services and things like that. So the basic idea is depicted in the top part of this slide, where you see that the overall chain has different level of visibility. The value proposition for Miranda is that the digital twin should be proactive, pervasive, and adaptive. Proactive because we want not only to detect threats, but we want to anticipate threats. So we want to have models for predicting threat propagation. We want to have a mechanism for threat hunting, so to understand what kind of threats the system is vulnerable to in its current configuration, but also in alternative configurations. So the idea of a digital twin, as any other digital twin, is the capacity of trying and investigating alternative configurations, both in terms of service configurations and service composition, to see how the system attack surface changes. And this can be done, running these twins under different conditions can be done by using the prediction tools to emulate, to predict possible data and how they could evolve in a different manner in the future. So not only considering historical data, but also taking into account different evolutions of this data, things that we typically do with AI-based algorithms. And the other tool for investigating is the sandbox environment, which is used to replicate part or the entire services in a safe environment when we can change its compositions, we can change its configuration, and see how it behaves under the current real or alternative inputs from the real system. The second property is pervasiveness, which means that we want a system that goes into the detail of the current service composition. So, for instance, what we want to know is to build very deep graph of all assets and their relationships. For instance, we are able to discover the current compositions of Kubernetes services, to link them with virtual machines or servers that host them, to link virtual machines with the servers that host them, and also to correlate virtual machines and containers to the internal software artifacts that are using to build them. So, for instance, we map service Kubernetes containers to Linux namespaces. We map virtual machines to the hypervisors that create them and things like that. Everything is described. We try to describe them with common emerging standards like Cyclone-X for the XBOM. Okay, we are working on that because we found that the current definition is mostly software-oriented and does not cover well the whole range of services that are indeed deployed in a typical environment. Okay, but this is things that we are still working on. Finally, the adaptive property. We know that with service chains, because they typically use self-provisioning interfaces, they use APIs, they use service-oriented architectures, are typically change over time. So maybe I'm deploying today my service in a cloud provider infrastructure, then I have some problems there. I needed to move this to another service provider without almost, let me say, any effort, because by using the same service templates, deployment is a matter of minutes, not of hours, like in the case of configuration of a physical service. So when the configuration changes, where the infrastructure changes, probably I have different kinds of logs, different kind of services, different kind of traffic, and so we implement things like the dynamic parser generation, so the ability to automatically understand the structure of log files, so to not rely on any specific structure for parsing specific logs from a specific application. We also implement adaptivity by context-aware response, which is by mapping the current logs and the security-related events to the system topology we derive with XBOM. And we also build threat intelligence and map threat intelligence to the current system to build new stories, to understand new threats from open source intelligence and things like that. Basically, the part behind the general value proposition, we are also implementing a set of capabilities in our system related to monitoring, detection, hunting, and response. So, okay, I think I already introduced most of these. We started with a very general, not so general, but quite precise framework in mind, which reflects the general concept I described. I just described them. So we have in our idea there should be this kind of cybersecurity digital twin, which is the intermediate layer in this architecture, which is responsible for discovering the composition of the systems, its dependencies, to emulate, to predict the evolution of the system, to allow to understand how the output of this system change with different inputs or with different configurations. And this is done by directly interacting with security agents deployed in each domain. On top of a twinning layer, there is the cybersecurity processes. They are exactly the same kind of processes already found today in many applications, in many environments, but the difference is that they are enhanced to leverage these capabilities of a digital twin. Another thing is the possibility to federate these twins to build the overall large vision over the whole computing continuum. So the idea is that each domain exchanges information about the assets and dependencies in its domain with different level of visibilities based on trust concerns. And then each provider has the visibility of the whole system and can apply its own security processes. This scheme is thought both for being applied by each provider independently or also by sharing the whole model to an upper layer organization, for instance, a managed service security service provider or a national authority, a national ECSCI, for investigating threats at the national or European layer. What we are now at the end of the second year of the project. So we are delivering, we are now integrating our platform, and the platform is in part already integrated, but we have still to release it. We hope that we will able to release the first version of our free platform, which will be open source and free of charge by 1 or 2 months at latest. Basically, we included support for a number of agents in at the low level. Typical agents that are used today, like the bits, network monitor tools like fprobe and probe, and also the capability. This is something new that we built in our system, the capability to create XBOM of entire services, not only the software. Okay, we can integrate software BOM in our system, but we can. The main important thing is that we can discover the service composition. We use OpenC2 as the only interface to interact with different agents, and we implemented a lot of profiles, not a lot, 4 or 5 profiles, which are currently missing for controlling file log agents and the network sniffers. And we also are able to create automatically the data landing pipeline, so to automatically configure the whole pipeline that collects data and deliver it internally. Internally, we have a set of models and simulation tools for understanding which threats affects which components, to compute potential attack paths, and we have a lot of tools for investigating, like the IOC extractor, the detect mate tool to detect and automatically parsing logs, Deep Guardian with advanced AI detection algorithms, Taranis AI for building stories and exchanging threat intelligence, the threat sharing API to exchange threat sharing with other platforms like MISP, and the SID tool to detect attacks in the log of a system without AI. More tools are will come in the next year. It will be integrated in the next months, so to create the full range of services and application for Miranda. As Miranda, we also integrated most of the available tools in a commercial platform, Logstail. We will release, in any case, a free dashboard, which will be available for evaluating the system and for the community to develop further systems. And we now have to integrate additional tools and systems in another commercial platform, which is Sphinx. Okay, and all these tools make use of REST-based APIs and can be easily chained to create different combinations, different services according to the needs of a specific use case owners. Finally, very quickly, in the next year, we are going to validate our solutions in 3 use cases. They are 3 smart city services deployed in Wolfsburg, Germany, Genoa, Italy, and Athens, Greece. Smart cities are an interesting testbed for this project because they are increasingly built with by combining services and tools from different providers, including IoT devices, LoRaWAN networks, 5G networks, Wi-Fi networks, local networks, and data sets, data sources, and things like that. A lot of things combined together, usually from different providers. The use cases owners have already replicated part of their infrastructure just to not create problems with the production environment. The production environment will only be used to collect data sets for training our ML and AI algorithms. And then in the next months, we'll deploy the Miranda agents and we'll connect the use cases with the Miranda platform to perform validation and demonstration activities. We also plan to have a demo to the upcoming CloudCom conference in Paris in October, where we are going to organize a workshop with the other projects funded under the same call. So it's an interesting venue for everyone. I invite you to participate, to submit some paper, and to come and to see our demos live. If you need to know more information about Miranda, we have a lot of socials, including a website, Twitter, LinkedIn, and the email address, and also the YouTube video. So maybe I was a bit longer than expected, but I finished, and I'm here for questions, if any.
Thank you very much, Matteo. Very interesting presentation, and maybe see you in Paris in the CloudCom. But I was wondering, are there any questions? We have still a lot of people online. Haptamiu, Manos, you have any questions for Matteo? Basically, Matteo, my question is, how do you keep the synchronization in the digital twin? So what if there is some configuration change in the cloud, maybe some Docker container and so on? What are your latency boundaries? Things like that, right? A little bit on the practical side.
Okay. For that, the answer is quite simple. For now, we use a polling mechanism to retrieve the configuration every time the central platform wants to detect any change. And so the latency is based set by the time you need to query all the components. It's a recursive process where you start from the root service, the service you know. For instance, you know that you are operating a smart city service giving citizens access to a specific web portal, and then you start from that service. You need to understand from that service which other services it builds on, so you discover recursively other services, you query them, and things like that. So for now, the basic understanding is that Kubernetes is quite fast to answer and to perform the discovery process. OpenStack is much slower. For now, we are in the range. We are just trying to estimate more precisely this in these days, but we think the order of minutes is feasible in this case. And of course, it could be improved with a push mechanism, but this is a bit more complex to implement, so we haven't implemented this yet.
If my use case is needs lower latency, I need to poll more frequently, right? To put this way, I can configure that.
Yes, but the performance constraint here is given by the time each context agent needs to answer you. If you try to query, for instance, OpenStack to know the list of virtual machines, or try to query Kubernetes to list the current containers deployed in the environment, it takes time. It's not a matter of milliseconds. It's a matter of seconds. So this is what limits the polling. And of course, there is an overhead, because every time you query the system, you waste resources there. So, okay, for the moment, we are pretty satisfied with the polling mechanism, because if you look at CycloneDex and all the other XBOM mechanisms, there is no way to automatically discover the XBOM. Usually they are published on websites and you have to download them. So the possibility to query in real time and to build the XBOM in real time, because what we do is to build the XBOM in real time. So we don't rely on static and stored information. We query the different systems and we get this information. In the next step, of course, we can integrate this. One reason why we didn't integrate the notification mechanism is that it is not yet defined in OpenC2. So we basically use the plain OpenC2 definition from the standard.
Okay, thank you. Very informative. Haptamiu, what is the question?
Yeah, sorry, I have muted myself because there is a noise in the background, so bear with me. Thank you so much for the very interesting presentation. And what two things which captured my attention. The one is your proactive module as well as your adaptive module. And there, when you discuss, you mentioned that you anticipate events, and that is very interesting to me. That my question is, how do you what you call capture the events, and how do you predict such unforeseen events based on unknown data, and how do you evaluate the impact of that prediction you made on this event?
Okay, there are two ways for supporting the prediction in our cybersecurity digital twin. One way is quite simple. It's the sandbox environment where we run the system or part of the system with different inputs. So in this case, we can have these unexpected events as a result of different input conditions, like it was a fuzzing analysis based made on the system. The second way to for the prediction is to work directly on input data, because one of the problems today is that we have only historical data that might not include everything possible event. So what we are doing is to use generative AI to be trained with a past history and to see if we can generate different and unexpected events. Honestly, I cannot give you the full scientific understanding of this because it's not my field of research, but this is something that if you want, I can send you by putting in contact with a partner that is dealing with this issue.
I would be very interested to get more know about this, since I am doing a basic research around anticipatory AI.
Yes, there are two kinds of anticipatory events that we are trying to do in our use cases. The first one is about the traffic in a TCP/IP network, so network connections, network size, everything that could be not precisely measured in the past. And the other activity is on LoRaWAN traffic. So it's a bit different from the plain TCP/IP network. LoRaWAN has its own protocol and quite precise timing, and there is an activity in based on one use case where we are trying to predict possible evolutions of the system in the future, so that we don't need to know a priori. We don't need a lot of historical data available covering all possible situations to train the other algorithms.
May I comment, John, something? One more comment. Yeah, you know, the present modules, they don't generalize to unknown data. That is a problem we are dealing with. Have you managed to, what you call, to optimize models to what you call to generalize to unknown data not by training or by input?
No, I don't think so. But for a more precise question, we should talk with a partner that works on this item.
Okay, okay.
Thank you. Really very interesting. All the presentations were very interesting. And with that, unless we have any other questions, I would like to...
Question.
Brian? Yes,
John,
please.
I have a question. I'd like to just, yeah, if I may. My question was really about spatiotemporal scalability, but I think we covered the temporal in the first part. But how scalable do you see this asset management system to be? Because it sounds like you're dealing with a lot of different systems.
Sorry, can you repeat the question,
How
please?
scalable? I mean, there are two aspects to it. The spatial scalability. How many systems can you deal with? It sounds like you're trying to deal with a lot of very fine granularity, a lot in your XBOMs, very, very detailed. Have you experienced any problems around that, or do you foresee any problems, or how are you managing to handle possibly millions and millions of different objects?
Okay, this is something that we need to clarify in the last year of the project with the validation phase. There are, you are right, because there are especially two big scalability problems. One is the discovery of the resources and the assets, which, as I was discussing with John, takes time to be reported by the different interfaces. I said that querying OpenStack takes around 3 seconds for a small OpenStack installation. Probably this is not linear with the size of OpenStack. And Kubernetes is a bit faster, and also in this case, probably it is only partially linear dependent. The real scalability challenge, anyway, is on attack prediction, because I didn't have time to go into the detail, but one of the things that we do is to assign to link each asset to vulnerabilities that are retrieved from the common sources like CVE and the others. But exploring all possible paths is very, very time consuming, especially with formal logic algorithm we are implementing. So with tenths of resources, it is still quite tractable. With hundreds or thousands of resources, or even millions of resources, we have probably to split the problem into multiple sub-problems, into multiple subdomains to keep it computationally feasible. But okay, this is I don't have specific numbers for now. We have to evaluate this in the next year.
Did I understand you to say you're constructing attack graphs on top of the asset database?
Yes.
Well,
we are constructing attack graphs with a formal logic model.
Yeah. Then you have state space explosion, and that's a different kind of scalability.
We expect
Okay.
We expect this explosion, and this is something that we still yes.
Do you have a deliverable or something that describes the system? or have you published anything?
Yes, there is a deliverable 3.1, which is about this part on the discovery and the attack graph generation, which is publicly available on our website. You can download it. The website is the one I show at the end of the project, but if you want, you can drop me an email or ask. If you don't have my mail, you can ask to John, and then I'll give you the link to download the deliverable.
Thank you, Matteo. A lot of questions in the end. That was good. Good that people stayed. So just to recap, this was our first webinar of ECSCI this year. Let's meet in 2 months, September 21st, with a different cohort of the project. In the meantime, I also remind you to declare your interest for the book of 2027, and also for the standards and security standardization webinar we will be preparing for the end of the year or beginning of 2027. Maybe Haptam, I see you are in touch with European Commission, JRC people. We should get some support and speakers from there for this. Till then, thank you for this very good attendance on July 20th, which we know is challenging for a lot of people. Also, some people celebrating the World Cup since yesterday. And then have a nice summer break, everyone. Thank you very much.
Thank you.